two cells are connected to a load resistor, resistance 3.0. So this is our load resistor, and it is having a resistance of 3.0 ohms. And we have two cells, so this is representing one cell, and this is another cell, cell 1 and cell 2. So don't confuse with the resistor within a cell, right? So there are some batteries, or actually ideally there is zero resistance in a battery, but in real life there are batteries with having, and they have the internal resistance. We call this resistance as internal resistance, IR, right? So every battery got an internal resistance, and this is what is 0.8 ohms and 1.2 ohms. So actually it is a 6.0 volt battery, but it's having a 0.8 ohms internal resistance. So we have the electromotive force, which is representing the battery, and the internal resistance of each of the cells are shown. So these are internal resistances, and we need to calculate what is the current in the load resistance. So we need to find this is our load resistance, 3 ohms, and we need to figure out the current through this resistor, 3 ohms of the resistor, load resistor. So the strategy would be to, alright, so if I just calculate total resistance, see, Ohm's law suggests us that V equals to IR, right? So if I know the total voltage and total resistance, I will just make I the subject, and I will be equals to V over R. So I total equals to V total over V R total. Alright, so total current will be equals to total voltage divided by total resistance, and this is the explicit case. Okay, this is only applicable when the circuit is in series, right? And our circuit is in series. So this is a series circuit, no parallel connections out there. So we can use this formula, I total equals to V total over R total. Now what is V total? Alright, so we need to first figure out what is V total. So if I just check our two batteries, two EMF sources, they are connected. Ignore the internal resistance for some time and connect them directly, and you will see that they are connected in series, and this is 6 volts and this is 3 volts. So the total EMF you are going, because see, whenever the batteries are connected in series, like plus minus, whenever they are connected like this way, they are in series, and when they are in series, the total EMF will be the sum of individual EMFs, right? So the total EMF will be a bigger battery with 6 plus 3 is 9 volts. Alright, so you will be having a 9 volt battery together with the total resistance. Why? Because the batteries are in series, so their resistance will be summed up as well. So we are gonna get a bigger battery this time, right? A bigger battery with a bigger resistance, internal resistance, and the resistance will again the sum of two individual resistances. So 0.8 ohms plus 1.2 ohms is 2 ohms actually, 2.0 ohms, right? Now the new circuit will be this. So you have a 9 volt battery with an internal resistance of 2 ohms and a 3 ohms load resistor. Now the total resistance in your circuit is 2 plus 3, 5 ohms, right? So R total will be 5 ohms. Why? Because the circuit is in series. If you ignore this battery, the circuit will be in series, right? The current will flow like this. So the resistances will be in series, so we'll just sum up them, and you will get a 5 ohms total resistance, and V total is 9 ohms, right? So I total will be equals to V total, which is this is 9 volts. So we'll dividing 9 volts by total resistance, which is 5 ohms. So 9 by 5 is the total current, and 9 by 5 in decimal, because they have given us the options in decimals. So 9 by 5 will be equivalent to, so if you just divide it, so the correct option is 1.8 ohms, right? That is the total current that will be flowing through this 3 ohms resistor.